Alright, so let's look at question 10, which is our last question. It's a good idea to start by looking what your formula for your nth term is and the formula for the sum in this example. So I'm just going to write them up here. We know that the formula for the nth term is 1 over n plus 1, and the formula for the sum is n over n plus 1. Okay, so let's start out. First, I want to prove true for n equals 1. Alright, so I look at the left-hand side, which is my nth term. So my nth term, if I'm summing to the first term, I'm going to get 1 over 1 times 1 plus 1, which gives me a half. And then the right-hand side is the sum to the first term, which will be 1 over 1 plus 1, which is also a half. Okay, therefore we know that it's true. Therefore, true for n equals 1. And now we can move on. Okay, maybe we go from there. We are going to assume true. This wording is very important. You're not proving true for n equals k. You assume true for n equals k. And you can say where k is an element of natural numbers, but it's not an absolute necessity here. And then you just replace n with k. Don't forget that there are terms in front. A lot of you forget that and you just put the formula for the nth term and you replace it with k. No, you need to put those first few terms in as well. Then you can dot 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 k times k plus 1 is equal to k over k plus 1. So you're allowed to take that as a truth. Now you're going to prove true for n equals k plus 1. Right, when you're doing this, it's usually quite helpful to just write down what you're required to prove, but please put an RTP next to it or put it in brackets or make it colorful, something that I know is not part of your proof. So I just want to remind myself what I'm required to prove. I'm required to prove that left-hand side, then my second last term will be the 1 over k times k plus 1. One more term onto that is 1 over k plus 1 times by k plus 1 plus 1 plus 1 plus 1. Okay, that I want to prove to be equal to k plus 1 over k plus 1 plus 1. That's just what I'm required to prove, so I'm just going to put it in a block. It's not part of my proof. I'm just keeping it in front of my eyes as I'm doing a proof. Alright, so let's start with the left-hand side. You can even write left-hand side if you want to. You don't have to. Okay. So I'm going to start with my left-hand side here. And I'm actually going to write left-hand side. And that's 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over k times k plus 1, the second last term, plus, let's make enough space this time, 1 over k plus 1 times k plus 1 plus 1. Okay. Don't put your right hand side in. You can't use that right hand side yet. You've got to get there. But now, from what we have here, I'm just going to highlight it. What we have here, we know that that is equal to that. So I can replace this whole bit here. I can replace that whole portion with k over k plus 1. So I'm going to do that. I get k over k plus 1 plus, so look, we've got 1 over k plus 1 times by k plus 1 plus 1, which you could write as k plus 2 if you want. Okay, let's carry on. Actually, I think I'm going to go back and write it as k plus 2. It's a bit easier to work with like that. So let's put this all here, it's k plus 2. K plus 2. Okay, so my LCD is k plus 1, k plus 2. So I'm going to times by my LCD. So I've got k plus 1, k plus 2. Times that out, and I've got k squared plus 2k plus 1 over k plus 1, k plus 2. Let's just make a bit more space here. Okay. Alright, that is a perfect square, which is k plus 1 squared over k plus 1, k plus 2. I can cancel one of those k plus 1's out, and I'm left with k plus 1 over k plus 2. Make it look how I want it to look. K plus 1 over k plus 1 plus 1, which is, in fact, and you can go and check, exactly what I wanted on the right-hand side. So I'd say it's equal to the right-hand side. Okay, I'm not finished yet. I don't have to put all the in-between stuff. Actually, the most important stuff is saying, therefore, it's true for all n is an element of natural numbers.